All right, today we're going to cover SD-WAN, software-defined wide area network. Software-defined wide area network takes into account hardware equipment that it gets placed on premise at the customer's location, and it takes advantage of software development and advancements to realize a better redundancy strategy. Your typical redundancy strategy historically has been using BGP or Border Gateway Protocol, bringing in two data providers and using the same block of public IP addresses that go into your firewall or your systems. The advantage of that is that it does give you redundancy in with BGP. However, your secondary circuit is sitting there as a standby backup. It's truly just a redundant an insurance policy. You do have the ability to set it up to leverage both of them, but the failover and the traffic patterns of where traffic is being directed isn't very as clean as it can be. So you can manage that. The alternative is doing WAN link redundancy with like your firewall or an intelligent routed device, where WAN link redundancy allows you to set up a primary and a secondary. All of your traffic routes through the primary circuit. In the event that there is a circuit failure, your traffic will fail over to the secondary circuit, but any of those active sessions will drop and you will have to reestablish them. So this has a negative impact on any communication going out to cloud-based services that are doing SSL or secure socket layer and are trying to ensure that the session is always going from the same source and destination IP address. When you fail over between your primary and secondary carrier, unlike BGP, WAN link redundancy does not keep the same source destination public IP address. So any real-time applications like voice or video or going up to cloud-based services fail, and you have to reestablish all those sessions. So with voice applications specifically, the big challenge with that is that when you have that primary circuit fail, it goes over to the secondary circuit, and when the primary circuit reestablishes itself, all those sessions fail over to the primary circuit. So you have network event 1 on the primary circuit going down, reestablishing over the secondary. When the primary circuit comes back up, all those sessions drop and automatically route over the primary circuit, which means those active voice sessions, those video sessions, any connection going out that needs to be preserved from the same source destination to a cloud-based service, all have to start over again. So it has two negative impacts on you. So software-defined WAN goes beyond that and provides you with a primary circuit, a secondary circuit as far as 4 carriers deep. On this drawing that you see labeled Veracity SD-WAN non-HA, you will notice that there's some components in here that make up the SD-WAN environment or software-defined WAN. You have the VeloCloud Orchestrator, and you have the VeloCloud Gateway and VeloCloud Gateway 2. Those gateways actually live within Veracity's data centers, and there's a specific reason why we have it designed that way that I'll reference later on. So that's 2 of the 3 components that make up SD-WAN, and the last one is this appliance device, so VeloCloud Edge device that sits on premise. We then bring in a primary data connection from provider 1. In this particular case, we have it as Veracity, and we have another data connection coming through provider 2. This could be any third-party provider. It could be a broadband connection. It could be another fiber provider. You'll notice here that there's a cloud here representing provider 2, that then all communication from the VeloCloud Edge device that's on-premise routes through the data connection that we have going out to the internet and then into either one of the respective gateways for communication. In this drawing, you'll see that here we have red dots and blue dashes. Those red dots and dashes represent IP communication from the VeloCloud that are established up through to the gateways. And these are active sessions that are always nailed up that allow communication and identification of what the health of the circuit is. So the VeloCloud Edge device, which is the device that gets installed on the premise, and the gateways are constantly communicating. They're constantly exchanging health updates on, is there latency, is there jitter, is there packet loss, is the path that I'm going over the preferred path. It is the best path to get to whatever applications you are trying to reach. It also determines if the path is reachable, meaning if you lose connectivity to your next hop, meaning the next default gateway, it will detect that and route around that. It takes both the primary, in this particular case, provider 1 Veracity, and provider number 2 other, and it actually bonds those two circuits together to give you the aggregate bandwidth between both service providers. So previously we mentioned WAN link redundancy and BGP. Those have a primary active and a standby inactive circuit. So SD-WAN is able to take primary, secondary as far as 4 carriers deep and turn those into total aggregate bandwidth utilization for all of your data needs. It has better intelligence to leverage that additional bandwidth. You'll notice here I have a note that says Veracity issued IP addresses configured on customer firewall. Because we have these gateways sitting in our data center and a VeloCloud Edge device communicates with that, we're actually able to take Veracity public IP addresses, inject those into the VeloCloud gateways and make those part of our backbone BGP routing, and take those public IP addresses and run those over the IPsec tunnels. That's what's represented by the blue dashes and the red dots, and put those on the LAN inside of the VeloCloud Edge device. This allows us to put those public IP addresses on the customer's firewall, and we're able to preserve any traffic that comes from the customer's local area network or LAN, and route that over through our VeloCloud Edge device through our gateways, and then egress out to the public internet. This ensures that all services, when there is a failure event, or when we're leveraging forward error correction, a technology that SD-WAN uses, or link remediation, where it remediates or attempts to correct for issues going on between on the upstream carriers and route around that. That's what we refer to as link remediation. By having those public IP addresses, we eliminate an issue that most other VeloCloud providers are unable to address, and that is doing double NAT. NAT stands for Network Address Translation, and we won't go into the details of what issues though that creates, but we're able to solve for that, and it makes for a very compelling offering when we are competing with other SD-WAN providers. So those are the three components: VeloCloud Orchestrator, VeloCloud Gateways, and then the premise equipment VeloCloud Edge device. Those are the three items that make up a software-defined wide area network. Next, what we'll do is we will jump into the Orchestrator. This is where all network administration happens. So you'll see here, this is the landing page for the administrator. Down here in my dashboard, you'll see that there are multiple different references to different locations. This is where a customer that has multiple locations, retail offices, could jump in and see all the VeloCloud devices. So if I click on Executive Conference Room, this is a VeloCloud Edge device that sits in our office, and you'll see here that as we drill down into that particular VeloCloud Edge device, that we have three data connections. One's called Off-Campus Telecom, the other one is Veracity Networks LLC, and the third one is for AT&T Wireless. Now, keep in mind that we have an active primary and an active secondary. You can see what the status of the communication between the edge device and the gateways are, and what the status of the health of the IPsec VPN connectivity. You'll see here that they're on the interface is WAN type, and then we have gigabit Ethernet 1 and 2, and then we have this third connection that's specifically in standby, and we'll talk about that in just a minute. Over here to the right, we see throughput and bandwidth, so that you can actually see how much throughput and how much bandwidth is available or being used by each respective circuit. And as we expand this option over here, you can see here that we're actually monitoring and have real-time view of packet loss, latency, and jitter. And all of those, for a network administrator, allows you to jump in and do a quick view and determine if the health of each respective data connection is what you should be expecting. Clicking through, we have QoE, which means quality of experience. You'll see here that we have the before and after, and each respective data connection. So the Veracity Networks LLC, Off-Campus Telecommunications, and the AT&T Wireless. The reason why the AT&T Wireless is showing red or critical is because it's in backup state. We will only send traffic over it if we lose our primary and secondary data connections, and it's set up and designed to do that from the beginning. These quality scores over to the right refer to the actual quality of the circuit, and then the quality score after, when it goes through the software-defined WAN wide area network VeloCloud Edge device and it implements forward error correction and link remediation, will actually smooth out the quality of that data circuit in the aggregate. So you could potentially have off-campus telecom reporting an 8 out of 10, and it would show in a yellow, meaning it's at poor quality. But because we're able to route around that, the aggregate improved experience through the VeloCloud enhancement would actually result in a 10 or a 9 plus in the quality. So as far as the end user is concerned, sitting behind your network, even though you have a circuit that is not performing very well, the result for them is that the quality will still appear as if it's better. You won't be down, or you won't experience drops when we begin routing around that, because we do what's called packet duplication, and it's sub-second. So within 500 milliseconds, when we detect a circuit is down, that we have latency jitter or packet loss, we will route around that. But those sessions will not drop because we duplicate those packets and send those up to the gateway. So the last item that I'd like to talk about as far as the orchestrator is concerned is going in and actually taking a look at live traffic running across the primary and secondary circuits. You'll see here that Veracity Networks LLC is sending constant communication between the edge device and the gateway that we referenced in the drawing. And one of the things I like to do is demonstrate what a phone call looks like between a phone that is connected behind the VeloCloud. So we have a Polycom IP handset that plugs into a premise-based session border controller in Edgewater, and then that Edgewater is plugged into the VeloCloud Edge device, and it has a public IP address on it. So I just made a phone call from the phone out to the public switch telephone network, and you'll see here that off-campus telecom is now carrying that voice traffic. We went from next to no traffic to 34.41 kilobits per second, and that's UDP traffic, and UDP is the connectionless protocol that's used when we're doing voice over IP calls, when we have an active call where we're exchanging voice communication. So what I demonstrate now is I will actually, on the VeloCloud Edge device, I will go physically to the secondary connection, and I will unplug that connection, and the call in a normal scenario doing BGP or doing WAN link redundancy would fail. But you'll notice here that off-campus telecom, where we were formerly carrying all the voice traffic, you see that there's no additional traffic going through there. It basically shows that there's 0 bytes because we've lost connectivity. And Veracity Networks LLC actually picked up that voice communication, and the call continued being processed. So that all happens seamlessly. With WAN link redundancy and or maybe BGP, where you're having latency jitter or packet loss because of some type of network event, the network administrator would have to go in and actually take that out of service. With SD-WAN, this all happens and is built in with the software application taking that into account. Now, I referred earlier to the AT&T wireless card that's sitting in backup. We can plug in, whether it's Ethernet based or USB based on approved devices, a connection that is backup to take into account that maybe you have a fiber seeking backhoe that goes in and cuts all your connections, and the result of it is that both your primary and secondary data connections go down. So I can unplug the circuit associated with Veracity Networks LLC, and you'll notice that now becomes critical and down, and the AT&T wireless card within a matter of a few seconds picks that up, and voice calls begin routing over that, which for a business is really important. You will not experience a disruption in communication. You'll be able to continue making and receiving phone calls. You will be able to continue processing credit card transactions, and this system is set up to send out alerts, whether it's email or SMS, so that your managed service provider or your IT vendor or whoever is responsible for managing this will be notified, so they can reach out to their carriers to launch a service ticket to get these systems restored. So that, in a nutshell, is the power of doing software-defined WAN. I mentioned earlier that doing either BGP routing or WAN link redundancy would result in a failure on the first circuit going down and having to reestablish all those sessions. With SD-WAN, I have now plugged in one of those circuits, and you'll see that AT&T will go from being the active data connection to inactive, and Veracity Networks LLC will become the active session, and all of the voice traffic will fill over to that. And I can also subsequently plug in the original circuit, which was off-campus telecom, and those will become aggregate bandwidth for all data communications. The AT&T will go back into a backup state, meaning we're not sending any data over to any longer. And throughout this entire process, those voice calls, that data communication that's going on will be preserved, and there will not be a disruption. So you can see on Veracity Networks LLC, we're now sending about 40K of UDP traffic, which means that voice call was preserved through the primary failure, the secondary failure, over to the AT&T wireless, and then it began failing back, and we did not drop it throughout the entire process. So that is really compelling and really powerful, and a great selling point for network administrators and businesses that have that demand better than your traditional 2 nines, 3 nines, or 4 nines uptime. To finish out, I'll go ahead and provide you with a video of SD-WAN and what the power of it when we're doing real-time applications, in this particular case video streaming, and what it looks like with and without SD-WAN on 2 different service providers, 2 of them with dual circuits, and then it will lead into ultimately a single data connection with and without SD-WAN, and where we begin introducing packet loss from 2 to 5% of packet loss. And you'll see in the video what the audio through the video, is it going to get picked up here, or is it only going to get captured here? I don't want it to be, we don't want to hear it twice, right?
Right.
So do we...
That's just a microphone, it's not a speaker.
Will you be able to pull the audio sources back?
Well, the thing is that's going to be the system audio I was asking about.
Okay, so it's going to capture that. Yeah. That's all I care about.
It probably will hear it, but you can just mute that.
So I'll go ahead and begin playing this video, and
Oh, okay,
yeah.
sorry.
No, I'll go ahead and begin playing this video. And you'll see the different scenarios where SD-WAN provides better performance with multiple different carriers, even when we introduce packet loss all the way down to a single data connection.
Let's look at an example of how VeloCloud remediates packet loss and jitter on transport links and protects high priority real-time application performance. Here, we use video as our high priority real-time application. Video on the left is going through a VeloCloud SD-WAN site, and video on the right is going through a site that does not have VeloCloud SD-WAN. There is no difference between videos because there is no packet loss or jitter currently on the transport links. Let's confirm that by looking at the VCO. There is no packet loss on either of the links that are connected. Let's go ahead and add 2% packet loss on one of the links. I'm adding about 2% packet loss on one of the links at both the SD-WAN site as well as the non-SD-WAN site. As you can see on the right hand side, the video at the branch that does not have VeloCloud SD-WAN starts experiencing packet loss and shows all kinds of artifacts in the video. Whereas on the left hand side, the VeloCloud Edge is able to re-steer the traffic such that you don't see any effects of packet loss. So let's confirm this by looking at the VCO. The VeloCloud Edge was originally using the Comcast link to carry the traffic, but as soon as it detected packet loss on that link, it was able to move the video flow to this MPLS link in a sub-second fashion such that you don't see any effects of packet loss. The second scenario is where you have packet loss on both the links connected. So let's introduce about 2% packet loss on both the links. Now let's look at our video application again. As you can see, at the non-VeloCloud site on the right hand side, the video application continues to experience severe degradation and artifacts on the video. Whereas on the left hand side, the VeloCloud Edge now remediates that packet loss across two links to protect application integrity. We can also confirm this by looking at the VCO. The VeloCloud Edge is now using both the links and performing link remediation. Initially, it was only using the MPLS link to carry the video traffic, whereas now it's able to use both the link to maintain the quality of the high priority video traffic. The final scenario is where you have only one link and that remaining link has packet loss. So to create this scenario, I'm going back to the traffic simulator and take down one of the links available. We are taking one link down on both the sides and the remaining link has about 5% packet loss. So let's run this simulation and see what effect this has on the video. The video on the non-VeloCloud branch on the right hand side continues to be severely degraded due to the packet loss on that single link. On the left hand side, however, the VeloCloud Edge is able to remediate the link through error correction and mitigate the effects of the 2% packet loss on that link. We can confirm this behavior by looking at the VeloCloud Orchestrator. The MPLS link is now down, and the only remaining link, which is the Comcast link, has about 2% packet loss. The VeloCloud Edge detects this loss of link in a sub-second fashion and is able to remediate the 2% packet loss on the remaining link to maintain app performance.
So in summary, SD-WAN improves on traditional failover strategies. It makes the process for failover less complicated and more seamless. It takes into account prioritization and real-time applications and preserving those in a failure event, but it goes beyond that and actually looks upstream for latency, jitter, packet loss, and uses link remediation to route around that. So we feel like this is a valuable product, and rather than it being a nice to have, it's becoming needed. It is needed infrastructure for customers who have a primary and secondary data connection or have a requirement for greater uptime.